So to explicitly solve this, we'd isolate y and take our derivative. To implicitly solve it, we're going to just leave it as is and make small changes till we get to the same solution. Does that make a little more sense? Okay. So I'm going to break this up because if we're doing it to one side, we've got to do it to the other. So just to make it a little clearer, we have d dx xy, d dx before. And this is just our notation for taking the derivative with respect to x. So what kind of rule are we going to want to use here? Product rule. Okay. So with that, we're going to take the derivative with respect to x of the first term, which gives us a 1. And then the derivative of y with respect to x, do we know what that is? Is that clear? dy dx. Right. We don't know right off the bat. Plus, and then we just have, oh, that was, you guys should have stopped me there. Not a product rule. Okay, that's why. Okay. And then we just leave the first one there and take the derivative of the second, which is our dy dx. And what about the derivative of 4 with respect to x? 0. Do we know why it's 0? Because it's a constant. And the derivative is going to tell us the rate of change, right? So if we're looking at a function on a graph here, we're looking at the function f of x equals 4. How much is that line changing? What's our slope? It's not changing, right? So that's why our derivative gives us a 0. So now we've gotten here, and we just have y plus x dy dx equals 0. So we're okay with that? Questions? So the next part, we want to isolate dy dx. Why do we want to do that? We're finding the derivative. So we want, isolating dy dx is going to give us an equation for our rate of change, or our slope. It's the same as finding f prime of x. So we want to have, we don't usually write our functions with f prime of x right in the middle of it, right? It's f prime of x equals something. Right? Okay. So we're going to isolate this by subtracting y over. So x negative y. And then dy dx equals, we divide by x. Yeah, you got it. Okay, so we've gotten there. So the next thing we want to do is use our new equation for our derivative or slope to find the slope at our given point. So we're just going to substitute in. That's pretty straightforward, right? And we end up with dy dx is negative 1, negative 4, which just gives us a negative 1/4. So that step's pretty simple, right? And then our fourth step is we want to find the equation of the tangent line, right? That was our primary goal. And so now we have slope at a certain point. We have that certain point. So all we need to do is substitute into point slope formula. And what do we end up with?